So this class will be discussing about FBC boiler. FBC stands for fluidized bed combustion. In 1921, the first fluidized bed being used successfully in Germany. The fluidized bed combustion has emerged as a feasible alternative and has significant advantages over the conventional firing system or the conventional boilers. And there are a lot of benefits that is offered by the fluidized bed combustion boiler, such as reduced emission of SOx and NOx. There are a variety of fuels that can be used in the fluidized bed combustion boilers, like coal, and even low-graded fuels like rice husk, wood chips, and other agricultural waste can be used. The capacity of the fluidized bed combustion boiler can range from as low as 0.5 ton per hour to even 100 tons per hour. So this is the mechanism that is used in fluidized bed combustion. So here we see the first diagram where the sand particles are just resting, and on the second right diagram we see compressed air is passed from the bottom. So when the compressed air is passed from the bottom, the bed becomes fluidized. So it is no more solid. It becomes even the sand particles acts like a fluid. Now the second portion, you can see the granular solid remains in the layer on the top. It doesn't come down, but here it mixed rapidly when compressed air is passed and when the bed acts like a fluid. Here also in the third diagram you can see two solid objects are resting on the sand, but when becomes fluid by passing air from the bottom, then these two solids get immersed. And in the last diagram we are having the heat transfer. When it is a solid, then the heat transfer is less, but when it becomes a fluid by passing compressed air from the bottom, then this particular bed transfers heat rapidly. Now the fluidized bed has a lot of good characteristics in terms of thermal performance. The fluidization largely depends on the particle size and the air velocity. So in the combustion process, there are basically three things which are very important. One is the temperature, second one is the turbulence, and the third one is the time. In fluidized bed combustion, the turbulence is the most important and the most advantageous thing. If sand particles in a fluidized state is heated to the ignition temperature of the coal, and then if the coal particles are passed through that, then the coal particles are ignited and combusted rapidly, and the whole bed attains a very uniform temperature. And the next characteristics of the fluid bed combustion is the combustion which takes place actually at a very low temperature, between 840 degrees centigrade and 950 degrees centigrade. Since this temperature is very low when compared to the ash fusion temperature, in the melting of ash and all the associated problems related to that, like deposition of the slag or other things on the surface of the boiler, can be totally avoided. This lower combustion temperature is achieved because of high coefficient of the heat transfer due to rapid mixing that is happening at the fluidized bed. Limestone is one of the important constituents which is used as a particulate bed, and this controls the emission of sulfur dioxide, nitrogen dioxide in the combustion chamber.